Okay, so this one, a good suggestion is to, if you have any lines, you can always just keep them going. And then even this one down here if you want. And then that makes it a nicer diagram to deal with, one that we're more familiar with, because the transversal goes through two parallel lines. And look, straight away I saw yesterday that there's this Z shape here, and that means have some information. This angle is the same as this angle, and that's a great place to start. If you're looking for angle BDE, remember that's the angle at D between B and E. So it's at D between B and E, so in the middle. This second question then, I definitely would refer back to your circle theorems, which in the book are on page about 490. So I'd use the book at page 490. This is a tangent, and there's something special about a tangent. You can use that or use your notes. We did that, and then you don't need to give the reasons, you just need to give the sizes. That's page 1. So question 2 then. Once again, if you want, continue these lines, and that might help. I can see a Z here again. There's another Z for there. That will help with that, and the same theory we used in the first question. Remember, if we have angles in a circle, they will all add. So x plus 2x plus 2x plus 75, they will all add to 360. So simplify that, and that'll give you the equation here. And then solve the equation in the second part using your algebra skills. Will help you with that. Question 3 then is our only coordinate geometry. Watch yesterday's video if you can't remember how to write down the equation of line A. So it's yesterday's. For B, drawing this, that is drawn. Draw a line parallel, so that means it has the same slope. So if it's y is equal to something, x plus something, I know that the slope of that one is 3. The slope of this new one must also be 3. And we know that the line passes through the point 0, 2. 0, 2 goes through that point. That's the crossing of the y-axis, which means I can fill in 2 here. So I'm drawing this line. Okay, and once again, watch yesterday's video if you're not entirely sure how to do that. Okay, I've kind of done that part 2 for you. Hey, Pat. One second. Okay, sorry guys. No, I'm back online. Okay, so that's the answer to that. I've done it. I didn't mean to do that, but that's okay. Next one, question 4. So it's isosceles. We should be able to deal with that. You can go back to your triangle theorems if you want. What page are they on again? On page 111, if you're unsure what to do here. This one, regular polygon of n sides. That means how many sides. So for instance, a polygon with 4 sides would have n equal to 4. So use the interior angles maybe on page 114 from the book, and we've done that before, and maybe that will help page 114, getting the interior angles and the end sides. So it's going to be a bit tricky because you use the fact that this is an isosceles triangle to get maybe this angle as well. You need to think about that. On that page. Okay, so for question 5, the diagram shows a circular pool of radius 2.5. Okay, calculate the shaded area. So this is one of those subtraction ones. You got to get the area of the square and then subtract the area of the circle. So you need to remember how to get the area of the circle. If you're unsure on those kind of shapes, you can go to between pages 218 and 225 has some examples of this. For this one then, okay, it's two isosceles triangles put together. And I'm sure you can maybe figure out those angles. I'm going to leave that one with you. And then write down the mathematical name for the quadrilateral ABCD. What would be the mathematical name for this? Where would I find that in the books? This might be able to help you. I think it'd be in chapter 11. So go to chapter 11, and somewhere in that you will find the mathematical name for that. Next question, question 7. So this is the front of the house, hexagon. The other 4 angles are all the same size. That's key here. Calculate the size of one of these angles. The front of the house is in the shape of a hexagon. So that means they're right angles, and I think all these angles are then the same size. And you have to use the fact that it's a hexagon as well. Remember, interior angles of a polygon for that. And that will be on page 115 or so. Have a look at that, and that might help you do that one. The next one, you're back to those circle theorems. So using about page 490 in the book will help you out with that. And once again, you can see that exterior angles, interior angles come up a lot. And that's on page 118 or so. Okay, moving along, question 8 then. This is a tricky one. A diagram shows a wedge, so it's a 3-dimensional shape. So calculate the area of a triangle. So a triangle will be half the base multiplied by the perpendicular height, so the straight up height. So you should be able to do that. The volume of the wedge then, remember, if you have the area of one side of it, so you have the area of this triangle, you can multiply it by how deep it is, its depth. So I think that'll be 24 in this case. If you're unsure on volume questions, go to page about 260 in the book, and around there has some help with that. Calculating B to F, that's going to be Pythagoras Theorem. Part 2 then, this thing rolls down. Okay, so if something rolls, you need to be thinking of circumference of a circle. So every time it rolls, it does one of these. That's the distance around the outside of the circle. Every time it rolls, it covers that distance, and that's a hint for that one. Maybe go to page 224 or so to look at the circumference of circles. The last part of that question then asks you for a net diagram. Hopefully you're okay at nets, better than the last time now. Remember, you unfold the shape. And each square of the grid represents 4 centimeters, so you'd have to take that into account. We have our wedge here, and that's 30, 16, 24. You have to take those into account when we do this shape. Okay, and then the surface area of the wedge. Surface area, we need all the surfaces. So that's on page 252 or so in your book. All the surfaces must be taken into account. Add them together. So many surfaces are on that wedge. If we look back, I think, and there's at least 4 surfaces maybe there's 5 surfaces, but you need to figure out how many surfaces are there. So if you're only doing 1 or 2, that's not enough. Think about that shape, what that shape would look like in real life. Maybe have a look at an actual wedge. How many sides would it have? And you have to get all the surfaces for that. What are the shapes of those surfaces? Well, there's a lot of rectangles, and there's definitely 2 triangles. So that's it. All right. So what'll be due for Monday? Get all this done, please. And we'll have a look at how well you're doing that. If you want to work ahead, on Monday we are going to be looking at transformations. So shapes when they're moved, we did this last year as well, moved, reflected, translated, enlarged, and that's, if you want to work ahead in that, that's chapter 22 from the book if you have some extra time. You're going to have some extra maths tasks, not many. It'll be on transformations, I think, and that will help you get ahead. So there's going to be, so clear your maths tasks as well. This, to look ahead to transformations, is voluntary. This must do your maths tasks and have this worksheet. You need to have this worksheet completed. If you have any issues, I'll stay on the line here, and you guys can check back in and just maybe if you do